Hi, my name is Daniel Svoboda, and I am a NLP research scientist at Johnson and Johnson. I'm here to talk about my project, which is called template-based information extraction with Dendograms to classify news articles. So this project is a project designed to automatically classify news articles and possibly even research articles into a dendrogram structure that would allow people to search everything through finer points of granularity. About me, I have a master's in machine intelligence from Stevens Institute of Technology in Hoboken, New Jersey, and I've had 10 years of experience in the machine learning world. My interests are natural language processing and time series. I'm hoping to use NLP in the healthcare field. I keep up to date with the latest NLP algorithms and infrastructure. Some of my hobbies are traveling, tennis, psychology. Also, to use GPT-3 to train it like a philosopher. And I have my contact information here. Um, so the problem is, how can we automatically classify news articles? So when someone receives a news article, we would want to be able to put it into a certain field, but it can be tedious to read through the article and figure out what category it belongs to. It would waste a lot of money and time resources. Also, as a helpful thing, since there are now thousands, maybe even millions of research articles, how can we automatically sort them so that a researcher finds the most relevant articles on which to get like new insights for their research? NLP can definitely help. NLP has now been using machine learning and has lately been making lots of strides in classifying clustering text with Word2Vec, Glove, BERT, and so on. So the normal problem in NLP is classification, which is called supervised learning or learning with known labels. Um, cl- Clustering is known as unsupervised learning, where we don't have associated labels associated with the text. So it's more of a data knowledge inference. A normal method in NLP would be to transform the text to some numerical vector like TF-IDF for word embeddings, following by training with a machine learning model. Unsupervised clustering of unsupervised clustering of articles means that we have no idea what the classification is, and we want to infer data from it. So the normal route is to get another numerical vector followed by dimension reduction and some form of clustering algorithm like k-means. The downside is that we can only get frequency of vocabulary or rarity of words with TF-IDF. News articles are always rich in linguistic structure and vocabulary. Linguistics is now state-of-the-art field that's been built off with NLP and has formed like a feedback loop. We do know that, like, let's say the linguistics of a technology article will be much different from the linguistics of a business article. So, is there a method that we would know to help take advantage of the linguistics in order to get more of a linguistics rich type of clustering? So, as a matter of fact, there is an implementation of this method can be found in a paper by Nathaniel Chambers and Daniel Jurafsky called Template-Based Information Extraction Without the Templates. So, the talks about the normal methods of NLP, such as getting entities and supervised learning. The alternative approach would be to use clustering of extracted templates and semantic roles that follow closely the linguistics of the article. Using these templates and semantic roles, we can infer the category of a document with clustering. So, what are templates? Templates, as defined by Jurafsky's paper, are event patterns which can be formed from either a noun in the WordNet vocabulary, or and a verb, or a verb and a head word of a syntactic object. So, briefly, head word would be when doing a part of speech tag tree. Um, it You normally get like the part of speech tags going down in a tree structure, along with like a noun phrase and a verb phrase. So at the top of the parse tree would be what is known as the head word, which forms like the overall structure of that syntactic object. So examples of templates could be explode, explosion as a verb, along with like a noun such as bomb. Um, so automatically you would see in this linguistics that this would refer to terrorism, for example. So also extracted from these entities, like in the nouns, would be people, things, etc. Um, when we get, for example, the word killer as a noun or as a head word, we would know that we would try to infer the entity as a person, as a bomb, as a thing, etc. So using NLP, we would be ready to extract these verbs, nouns, and named entities from a given paper and prepare it to set up these templates. So now we get to what's called slot filling. So slot filling is with these extracted nouns, entities, and verbs, we can form them together in order to get the templates. So in order to get a template, we have to create sub-templates, subcategories, which is known as a process called slot filling. So for example, if we have a template that refers to bombing, we would have one slot filling that would refer to an object that explodes, is diffused as a bombing instrument. Another subtemplate or slot filling would be a bombing perpetrator, and that is a person who detonates a bomb, sets it off, etc. All these various slot fillings are compatible with agglomerative clustering in the template, in which we have the subclusters and they branch together into more general templates and an overall template. So these extracted words plus distant measures are clustered with agglomerative clustering to find these templates in an unsupervised manner. So here are examples of templates and the slot fillings. So if we were to have a bombing template, we would have as various slot fillings perpetrators, and we would have the various verbs and head nouns and WordNet nouns to distinguish these, such as plants, hurls, stages, suspected. We'd have target, we'd have a police. If we were to have a weapon smugglings template, we would have for one slot filling a perpetrator, and he would be in a personal organization, who smuggles, is seized, captured. We'd have police slot filling, someone who raids, seizes, captures, confiscates. We'd have an instrument, such as a physical object that is smuggled, seized, or confiscated. We'd have election templates. So, election templates, you would have slot fillings for voters, for governments, for candidates, etc. So based on these paper ideas, I created a practical program for clustering. So some direct ideas from these papers are to do a count vectorizer of the lemmatized verbs. So basically to get a verb, lemmatize it to its base form. So runner and running would lemmatize to run. So we would have one count vectorizer to count these verbs. We'd have another count vectorizer of lemmatized verbs and their dependencies. So their dependencies would be whether they are a subject, an object in the corpus. We would have a count vectorizer of lemmatized verbs and their part of speech tags, such as noun tag, adverb tag, etc. And finally, we would have a count vectorizer of two events. such as verb pairs, along with their dependencies. Their dependencies indicate how one verb interacts with another, like as a modifier. So these can normally be implemented in SPACY or NLTK, where you can get, in addition to a part of speech tag, tag parser, you'd have a dependency parser to get these verb pairs. So some indirect ideas, which the paper kind of only hints at, but which I implemented on my own, was to get a count vectorizer of the part of speech tags on the idea that different templates will have different distribution of part of speech tags. Another would be to get a count vectorizer of the entity counts. So for all extracted entities, I would get the count of all the entities in the given document. That the idea is that, again, different templates would have different distribution of entities. I used Roberta sentence embedding with sentence transformers in Python to get the sentence embedding. The idea is that the attention mechanism found in Roberta would focus specifically more on nouns and verbs. And finally, I implemented topic modeling with Top2Vec. So the idea would be that the topics found with Top2Vec would form a rough outline of the templates that we are going to do. So again, the rationale for BERT and Top2Vec vectors is, again, with BERT using attention mechanisms to get the embeddings from the sentences. As you know, BERT uses attention mechanisms, which focuses more on some words and less likely on other words. So the idea is when Roberta was pre-trained, more attention would have been focused on nouns and verbs, and that is one idea to hack. Another is using Top2Vec, which automatically creates different topics. Each topic is encoded with a vector, and documents which get their distribution of topics are encoded as a vector. So that vector represents a mix of the different vectors that represent each topic. So the idea is that these topics will form a rough sketch of the templates that all the other data points will smoothly fill in. So after extraction of all these count vectorizers and vectors, we get data points in the 10,000s range. Obviously, we're going to have cursive dimensionality problems. So the best dimensionality reduction I found is UMAP, which preserves the topology of the data cloud from higher dimensions to lower ones. Then we perform dendogram clustering on these reduced variables in order to get the number of clusters. So by examining the cluster numbers that we get from dendograms, we can potentially infer templates or slot fillings in more finer granularity, and then see how they form together into more abstract templates. So one example I did was using CNN articles. I took 32 articles from CNN's website on 4 different categories: style, entertainment, travel, and health. Altogether, there were about 13,000 variables, so I used UMAP to reduce it to 16. And with agglomerative clustering, I initially set it to 4 clusters. So not all the news articles were picked up correctly. Some were mistaken for another cluster. So I then increased it to 8 clusters, and then using 2 numbers to represent each topic, it was able to find it perfectly. So here are the articles that I used. So using 4 clusters, you can see that the cluster numbers were 0 to 3. So the zeros are the health ones. They were all detected correctly. Entertainment had a 0 instead of a 1, so there was 1 error. Style had is denoted by 2, and they had 3 1s, which again was an error. And then finally, the travel ones, which are 3s, were all detected correctly. So using 8 clusters, they were all detected correctly, with health being 0 and 7, entertainment being 3 and 1, style being 4 and 2, and travel being 5 and 6. So here's a dendrogram. Here's a dendrogram that shows an application of the dendrogram to that reduced data structure. So you can see here that the numbers are pretty much consistent with the various categories. If you were to go down into these various finer templates here, you would see, for example, in entertainment, what is a very fine slot filling, followed by more broader slot filling, followed by more broader templates. So style articles were 22, 18, 17, 23. Health and entertainment articles in the dendrogram were 0 and 15, and they converged to a common template that included health and entertainment. So style and travel articles also converged to a common template. So it would be very interesting as a linguistic study to see which templates health and entertainment converge to, and see what templates they both had in common. Also would be interesting to see for style and travel, although that would be sort of more intuitive, given that styles might start out in different countries and then travel around the world. So using a dendrogram, someone can take a future CNN article that's not been labeled, put it through the dendrogram cluster, see what number it comes to, and then identify it in that category for their website. So here is something that might be more of interest for researchers, and this is cancer articles from cancer.gov. This also is a website that has daily news articles on the latest research in cancer. And these articles tend to come in an unstructured format that are based more on the time that they were uploaded. These articles deal with a mix of various topics such as social issues, immunotherapies, gene editing, surgeries, recurrence of cancers, etc. This template method can automatically cluster articles into the neater format that I previously demonstrated for CNN. Even better, these dendrograms can yield insights to slot filling subtemplates. So researchers who are looking for new insights into their research or interested in a very fine topic can use this dendrogram method in order to automatically classify articles into finer templates. So here are a list of articles that I used. I used 75. So apologies that it's a little bit too small to read, obviously. Here is the dendrogram structure that I was able to create after using the same method, getting all the embedding data points, using UMAP to cluster to 16, and then passing it through a dendrogram. So basically, in this dendrogram, we have 5 categories here. We have the first one, we have a second one, we have a third one, the fourth one, and the fifth one. So counting all the 75 articles and the 75 very sub-templates, I categorized them as group 1. I categorized another as group 2. The big one with the yellow, I categorized as group 3. We have group 4. And the last one we have is group 5. So by by more closer analysis of these articles that were classified into these finer dendrograms, I found these results. Group 1 dealt with resistance to cancer treatments along with causes for recurrence after operations and/or therapy. Group 2 deals with initial or secondary methods of treatment that were able to successfully inhibit or prevent recurrence of cancers. So a dendrogram, a very fine cluster at the end, would refer to a very specific method, with a more broader cluster referring to a mix of one or two of these methods. Group 3, which was the large yellow one that you saw here, dealt solely with immunotherapy treatments of various cancers. The last two dealt with more generic topics. So Group 4 dealt with monthly roundup of articles, and Group 5 dealt with social issues dealing with cancer, such as discrimination in testing, financial problems, telehealth, etc. So, looking at a finer granularity, we can see how this could be potentially of interest for researchers in the cancer field. So, document 53 and 0, which I marked here, dealt with immunotherapy solutions on specific DNA proteins in cancer cells. So this was a subdivision of a very fine cluster. The next broader one included document 6. So document 6 dealt with immunotherapy solutions along with chemotherapy. So documents 53, 0, and 6 all converge to a higher cluster. So we could say this dealt more with with a more broader category of immunotherapy. It would be interesting to see what the chemotherapy and the DNA proteins had in common. Maybe a doctor could research it and come up with something novel. Another very fine cluster was 71 and 36. And this dealt with immunotherapy drugs for specific cases of lung cancer. So these two converged with the subcluster formed with 53, 0, and 6. So again, this forms more of a broader template for immunotherapy, which would be very interesting to investigate and see from the linguistics, the count vectorizers, what all of these had in common. So again, with documents 53 and 0, with the specific DNA proteins, a potential doctor could investigate those articles, or after putting in like thousands of articles and seeing which documents came to these very fine subclusters, it can expedite their research. They'd have a list of articles of them waiting for them. It would also be very potentially novel that they might potentially be able to find new insights by being able to see something that they might have missed before. So another one is document 69 and 32, which dealt with protein models of ketosis and inhibiting various forms of cancer. And this is dealing with the initial and secondary secondary methods that were able to successfully prevent cancer. Document 9, so 69 and 32 were basically divisions of a very fine cluster. So this deals specifically with protein molecules related to ketosis. Document 9 referred to protein molecules that found in Alzheimer's patients, which could potentially spread melanoma to the brain. These all converge to a higher subcluster. So in the initial and secondary methods that were able to prevent cancer, these form a cluster that would relate, for example, to protein molecules. So again, a researcher can either investigate these articles or, after scanning in thousands of documents, see if these documents converge to this very specific topic, and see if they can get any novel insights in using protein molecules in ketosis for inhibiting cancer. So a last finer example can be related to, this is also relating to initial and secondary methods to stopping the spread of cancer. So documents 68 and 39 used CAR T-cell therapy, which is a form of immunotherapy of using the immune system to attack a very specific cancer cells. So these two articles related to secondary treatments following an initial therapy such as surgery or chemotherapy in stopping the spread of cancer. Document 67 dealt with more radiation therapy. So it indicated that by using very intense radiation therapy after surgery for prostate cancer, it was able to inhibit and prevent the spread of that cancer. So these templates, these documents converged into a subcluster after which could indicate that these secondary methods had something in common which a doctor could be able to use specifically. Finally, documents 57 and 3 dealt with surgeries, secondary surgeries following initial ones to prevent recurrences of cancer. So again, 57 and 3 uh, converged to a higher cluster that included 68, 39, and 67. So from here, we see that we have a very fine cluster of T cell therapy. We have radiation therapy. These two look broadly different, but they may have some common words and terminologies that might be useful for doctors in order to see which higher insights that they can derive from. And finally, 57 and 3 also converge to the cluster with the CAR T cell therapy. So, for example, they use secondary surgery. So there might be, like, let's say, a mention of a surgery used in the CAR T cell therapy that was also done down here. A doctor could potentially look at if there were any commonalities of these surgeries or methods that they could potentially implement along with implementing these CAR T cell therapies. So again, a doctor can scan all these thousands of documents instead of having to peruse them, seeing what documents converged into these very fine clusters. So if they were very interested in the CAR T cell therapy, they could see which documents had numbers 68 and 39 and then start investigating them on their own. So in conclusion, the template method with dendograms helps to cluster news and potentially research articles into very fine subdomains. So these subdomains can be discovered by examining articles that were clustered into the dendogram, or we can potentially, in these fine clusters, we can examine the entities, part-of-speech tags, verb pairs, that were initially created and get a flow of the linguistics being used. So news or research sites can simply get the classification through this method instead of having to visually examine it or label it and then train a supervised classification model. So researchers can visually examine these templates and slot domains. So they can discover maybe very novel insights via the linguistics that might potentially be used in news or specifically research. So as mentioned, researchers can take the health articles in news, such as in cancer.gov or other more formal sites like the New England Journal of Medicine, and find a cluster domain. So a researcher who has like thousands or tens of thousands of papers can scan them with OCR into PDF formats, and then upload it to the algorithm, which would then automatically classify them into a given slot, which they can then examine on their own and see if there would be any novel insights that they could have for their own research and their own papers. So anyone else has questions before following up? Great, thank you.